So hello everyone, welcome back to Advent of Code. Today we are on a day 8 and today's task is called Playground and it goes as follows. Equipped with a new understanding of teleporter maintenance, you confidently step onto the repaired teleporter pad. You rematerialize on unfamiliar teleporter pad and find yourself in a vast underground space which contains a giant playground. Across the playground, a group of elves are working on setting up an ambitious Christmas decoration project. Through careful rigging, they have suspended a large number of small electrical junction boxes. Their plan is to connect the junction boxes with a long string of lights. Most of the junction boxes don't provide electricity. However, when two junction boxes are connected by a string of lights, electricity can pass between those two junction boxes. The elves are trying to figure out which junction boxes to connect so that the electricity can reach every junction box. They even have a list of all the junction boxes' positions in a 3D space, which is our puzzle input. For example, here we have 162, 817 and 812, which corresponds to x, y, and z coordinates in our 3D space. This list describes the position of 20 junction boxes, one per line. Each position is given as x, y, and z coordinates. So the first junction box in the list is at x equals 162, y equals 817, and z equals 812. To save on string lights, the elves would like to focus on connecting pairs of junction boxes that are as close together as possible according to the straight line distance. Straight line distance in this case is just a Euclidean distance in a 3D space, which equals to x2 minus x1 squared plus epsilon 1 minus epsilon 2 minus epsilon 1 squared plus z2 minus z1 squared, and all of that square under a square root. In this example, the two junction boxes which are closest together are 162, 817, 812, 425, 690, and 689. By connecting these two junction boxes together, because electricity can flow between them, they become part of the same circuit. After connecting them, there is a single circuit which contains two junction boxes, and the remaining 18 junction boxes remain in their own individual circuits. I want to go ahead and read how the rest of it goes, because they're now just explaining how basically the same thing, but just with different values. But what we need to do is, so we have these junction boxes and we have their coordinates. Each junction box is its own circuit also. So this is its own circuit, this is its own circuit, this is its own circuit, and so on and so on. And because of that, we have 20 circuits. They said that this junction box and this junction box are closest to each other by Euclidean distance. So when we will connect them together, we want this junction box will now be in a circuit. This circuit, the new circuit which we will have, will be with this junction box and this junction box. And so with that, we got rid of the two junction boxes. We are left then with a one circuit with two junction boxes and 18 junction boxes which remain in their own individual circuits. Our goal is to connect together 1000 pairs of junction boxes which are closest together. Afterwards, what do we get if we multiply together the sizes of the three largest circuits? Before we go ahead with our code, I'm just gonna say that this took me quite a while to solve. I would say around 5 to 6 hours, because this I had to understand a lot what was happening. At first I didn't understand what the task was even asking from me. Then I didn't understand how can, for example, these ones be each own circuit at that moment. And then just writing that code, it it felt very difficult. So I'm not gonna lie, this was the problem that I had to look up a lot of hints and ask around a bit to get some sort of help and check some visualizations to maybe see how it acts and whatnot. So yeah, um, what I'm trying to say is that some parts of my code um, aren't my own because it took me a really long time to try to solve this, and sadly, I don't have time to spend longer than what I did. But in the end, I managed to do it, and I hope the algorithm that we'll be implementing I'll be able to explain in simple terms. So let's start with writing our code. First things first, what we will do is, of course, parse our input, which we will parse on an example input from a text file. And I will just create a list called junction boxes that will hold our lines that we will get from our file. So we can go for junction box, just so we can be descriptive in F. Then what we do is we do junction boxes dot append. We do this line. As we know, each line here contains a contains a new line character at the end, so we can just append it. Actually, first of all, before we do that, since we have each value individually here, like the coordinates, I guess we can map them first into integers. So I will just write normalize junction box, which will be equal to which will map to an integer from junction box dot we strip the line of any new line characters or spaces, and then we just split it on a comma. And now we can append our normalized junction box, but we don't want to append a map. We want to append a tuple, and Python will handle the conversion automatically. So now once we have that, the next thing we will do is we will generate our so-called pairs and our circuits. And so we know that initially all of our circuits are junk boxes themselves individually. So I'll just write generate box pairs. Also, we will get to why we will also be generating pairs. I will provide junction boxes. And now we can just do circuits, which will be like a junction box with another junction box inside, which is itself for a junction box in our junction boxes. That word is starting to not make sense to me. Now what we want to do, once we have all of our circuits, we want to generate all possible pairs of our junction boxes between each other. So we will have, for example, this junction box with this one, this junction box with this one with this one, and so on and so on. And in Python, we can use a function called combinations, which we can import from itertools. And what it will do is it will return all possible combinations with a provided length. In this case, it will be 2 because we're generating pairs. So I will name this pairs of the circuits equals combinations of the said circuits and 2. I think it would be nice now to visualize how our circuits look like. Print circuits. Let me just call the generate box pairs with the junction boxes. Now we have something like this. I hope it's pretty enough to understand, but basically this is our key now, and this holds a set of other junction boxes. And in this case, it initially holds its own junction box, which makes it a single circuit. So this makes a single circuit that is connected to this one. This makes a single circuit that is connected to this one, etc., etc. I guess we can say that they're connected to it to themselves. And now to generate how the pairs would look like, we will just do, I need to actually do this for P in pairs of circuits, print P. And now we have, as we have said, we have 162, 817, 812 with this one, this same one, this one, and so on and so on. Okay, now once we have that, what we want to do is now sort our pairs based on the distance, because it will be easier to work with that, and we will immediately know which distances are the lowest. We can do that by creating a function that we will call Euclidean distance, where we can provide a first junction box and a second junction box. What we will get from them is their corresponding values. Z1 equals first junction box, and we will do X2, Y2, Z2 equals a second junction box. Now what we do is we get power, we get a X, Y, and Z terms of those points. So what we can do in Python, we can just use a pow, and then we can pass it x2 minus x1, and we pass it 2, which this means which exponent it will be. Since we want to square it, we will be using a2. We do pow of y2 minus y1, 2, and z equals pow of z2 minus z1 of 2. And now all we have to do is return a square root of the why I don't have it? Yeah, power we don't have to import, but to use a square root we need to import a math. Return method square root of a sum of all of those terms, x plus y plus z. Now once we have that, we will sort our pairs like this, and so we will do sorted. We will pass in pairs of circuits, and we will do it on our Euclidean distance formula. We will do lambda x, and what we can do is not just pass Euclidean oh my god, I don't know how to write Euclidean distance. We pass it a since we are working with those pairs, which is like pair of first junction box, and then that pair contains first and second junction box. We can provide coordinates of the first junction box and coordinates of a second junction box. And now what we will do is we will return both circuits, and both are sorted pairs. So what we'll do is do circuits and pairs, circuit pairs equals circuit pairs, circuit pairs from our function. Now we start writing a more complicated part of this, the more complicated part, the main logic of this algorithm. To now understand what we will do, we will go pair by pair individually by doing the while we are iterating through our how do you call it, while we are doing trying to find 1000 pairs as it said on the Advent of Code website or in the text. So let me just write a initial logic. We will do process circuits where we will pass in the same circuits, we will pass in the pairs, and we will have our current iteration. So we should have in our pairs, we will be iterating through, we will be accessing a pair with our current iteration, and we will have a junction box 1, which I guess I can just name box 1, and box 2, which is from which we can take our which we can access using our pairs on a current iteration. So I guess I can do like a print of this. So let me just do that. Process circuits, we pass in circuits, we pass in circuit pairs, and we pass in our initial this. So if I do this, now we will get our initial pair of these boxes, junction boxes. So what we will do now with this is we will be checking through each, not through each pair, through each circuit, we'll be checking if our box 1 is included in our current circuit, and if our box 2 is included in a current circuit that we are checking. I thought it would be better to visualize this extremely quickly. So for example, if our current pair is of box A and box B, this is what is considered now our closest pair. We will merge these boxes together, and now we will have a first group of boxes A and B. Now let's imagine our next pair is of box C and box D, and we also merge them, and now we have two new groups. Well, we now have two new circuits in this case, A, B, C, and D. And now let's say our next pair is of box B and a box C. So now since our box B is a member of this group and box C is a member of this group, we can merge these two groups together. Let me just mark that. We can merge these two groups together, and how the new circuit group or circuit would look like is A, B, C, and D. And so now we have our new circuit, and then we have however many left to check, and we do that for 1000 iterations. Okay, to now go right back into writing our code, we got our first boxes, box 1 and box 2, and now we will go through each circuit individually. Circuits, and then we will be checking if our box is in one of these if our boxes are in one of these circuits or not. To store a circuit for box 1 and to store a circuit for box 2, I guess we can create two variables, circuit 1 and circuit 2, which will both be initialized to none. We do this because box 1 necessarily doesn't need to be in a second circuit and vice versa. They're different boxes with different coordinates and might belong to a different group. So now we check if a box 1 is in circuits of our in this current circuit group. If it is, we update the circuit 1 to be equal to that circuit. If our box 2 is in circuits of a circuit, we just do circuit 2 equals circuit. And that's basically it for this for loop. And now what we can check if our circuits that we have just sort of constructed, don't equal to each other, that means it's good, and that means we can merge them. So into our circuits of circuit 1, we will update our circuit 2. We'll update our circuit 2, and we will then delete our empty group, all the empty group, because of circuit 2, because we merged these two circuits. Imagine you have like two buckets of water. You have bucket A and bucket B, and they're both filled, and then you pour all the water from bucket B into bucket A, and now that bucket A holds all the water, including from A and B buckets, but bucket B is now empty. So that's what we are basically doing. We are deleting the group. And now, once we have that, all that is left to do is check if our current iteration equals to 1000. And if so, we will again sort our circuits. Which will be sorted. And now, instead of sorting them again by the distance we did, now we will sort them by the number of junction boxes inside, or how large a circuit is. So we will do circuits of a circuit for circuit in circuits. Once we have that, we will just return, this will give us lengths, an array of lengths. So what we do is we go sorted circuits of a third last element times sorted circuits of a second last element and times sorted circuits of a last element. And now once we have done, all that is left to do is we return our process circuits, we provide circuits, we provide pairs, and we provide the current iteration plus 1. Why am I getting an error? Oh, okay, I remember. So for the example input, they only do 10 iterations if I'm not mistaken. Well, that, and because I failed to get the circuits of this one. And now once we have that, we can do, I don't know how to call this, maybe like mul of last three of three largest circuits equals this, and now we can do print of part 1, and we do this, and we should get 40, which is the correct answer for the example. And if we do it for my own input, we get 8 because I didn't update these to 1000 iterations. But doing so, what is now happening? Why is it taking? Maximum recursion depth. Okay, yeah, since I decided to go with the recursion, I have to do a small hack to increase the limit of how deep the recursion call stack can go. So I just do system.re, how is it? Is it set recursion limit? Where, I don't know, I guess we will just do like 10 to the power of 6. And now we can run this. And I get 122,430, which is the correct answer to my input. And now to continue with part 2. The L's were right, they definitely don't have enough extension cables. You'll need to keep connecting junction boxes together until they're all in one large circuit. Continuing the above example, the first connection which causes all of the junction boxes to form a single circuit is between the junction boxes at 216, 146, 977 and 117, 168 and 530. The L's need to know how far those junction boxes are from the wall so they can pick the right extension cable. Multiplying the x coordinates of those two junction boxes, 216 and 117, produces 25,272. Basically, now what we need to do is, with our input, continue connecting the groups until we are left with only one larger circuit, and then we multiply the x coordinates of the two junction boxes that were left. In this case, those two junction boxes that will be left will be our pairs, box 1 and box 2. What I will do is I will use this function again, and I will just define like a part 2, which is gonna be a Boolean flag to indicate if it is a part 2 or not. And I guess I will call this mul of like multiplication of x coordinates equals and process of these circuits. We provide in circuits, we provide in pairs, and provide in a first iteration circuit pairs, not pairs, and we set this to true. Now all that we need to do is provide first here a part 2 so that it can recursively call with this one too. Now we know that this must not be a part 2 in order for this current iteration to stop. We are doing this because the iteration can be much larger than 1,000 before our length of circuit is 1. So yeah, and now we just do if length of our circuits equals to 1 and it is a part 2, we will just return a box 1 x coordinate times a box 2 x coordinate 2. And once we have that, we can just copy paste this, change this to 2 and do this like that. So let me run this first for example, which we need to run only 10 iterations. Well, this doesn't matter, but it will matter for part 1. So I'll just run it through here. We get 25,272, which is the correct answer. And I won't use that REPL. I will use my terminal to run this one, and I can just remove this. And I run this, and we get this large number, which is the correct answer to my input. By far the hardest problem. I'm not really good with graphs at all and doing stuff with them, so this required a lot of exploration and understanding. I hope you guys have enjoyed though. I hope the explanations were good, and I hope you guys have also learned something. Until tomorrow, I hope you enjoy your days, and peace.